Good afternoon, or good morning, or good night, wherever you are in the world. Welcome to this second day of the Lift and Escalator Symposium. My name is Richard Peters. I'm one of the co-chairs of this conference. Delighted to welcome back a full audience today. We're completely sold out, which is lovely. So thank you for joining us. We much appreciate your patronage. So today we're talking about modernizations, and our first speaker today is Dr. Rory Smith, who is a visiting professor in lift technology at the University of Northampton and a consultant for us here at Peters Research Limited. He's got over 52 years of lift industry experience, during which he's held positions in research and development, manufacturing, installation, service, modernization, and sales. So he has a range of special interests, including robotics, machine learning, traffic analysis, dispatching algorithms, and ride quality, and numerous patents for his work. So join me in welcoming Dr. Rory Smith.
Thank you, Richard, and it's a pleasure to be here. I've always been interested in modernizations. I've been involved in modernizations perhaps my whole career. Along with other things. Probably the largest modernization I was ever involved with was the 240 lifts at the World Trade Center, the Twin Towers in New York, the 9/11 Twin Towers. It was a very challenging project, but actually all modernizations are challenging. So let's take a look at what we think the modernizations of the future are going to look like and what's involved in it. First question you have to ask when you're dealing with modernization is, why modernize? Why do we modernize lifts? Well, it's because of competition. That's why we modernize. And if we think about competition, we tend to think in terms of sports competition, one team competing with another team, and that's definitely competition, but there's also business competition where in this case we have McDonald's competing with Burger King for your hamburgers. But buildings also have competition. Buildings compete with each other, and they compete for tenants. So this is a picture of the New York skyline, and you see a wide range of buildings in there. So I'd like to give an example of a couple of them, two of them. One of them is the Woolworth building. This building was built in 1914. It's been modernized at least 4 times. The last time it was modernized was around 2010, and it still uses the original Otis gearless machines that have been there for over 100 years. It is having to compete with other buildings nearby, including the One World Trade Center that replaced the Twin Towers. And you can see them both in the same picture. And that was built 100 years later in 2014. Yet these two buildings are in a similar area competing for the same people, the same tenants, potentially same. Okay, so these are competitors, and they're very closely located together. You see them in the same picture. How do they compete? How do buildings compete? We know how teams compete, but how do buildings compete? Well, they compete on 3 different areas. One of them is location. And there's a cliche in real estate. What are the 3 most important things in real estate? Well, it's location, location, and location. And that's very definitely a major factor. But they also compete in price per square meter for leases, and the nicer buildings are going to get a higher price. The better locations will get a higher price. The buildings with old, outdated, ugly lifts will get a much lower price. And features. There are, features. What features do the buildings have? And so there's this saying in the UK, the 3 L's, the most important things in buildings are the loos, the lifts, and the lobbies. It's the same saying in the United States, but we use washrooms, lobbies, and elevators. Same concept, but that's where people spend their money, and those are very important factors. So these are the features they compete in. But will the future be different? Are we going to compete on different factors in the future? I think no. I don't think we're going to compete on different features. But lifts there will be 2 important sets of features in the immediate future that are going to be very important. And these features are the post-pandemic workplace requirements, and they're going to be very different. And then new technologies that are coming out that everyone's going to want and demand. So let's take a look at some of these. What are the features in the post post-COVID world. And we're still not quite at the post-COVID world, but we hopefully soon will be. And so let's take a look at the post-COVID real estate market. So what we're going to find is that some things we find about the existing market is the average commercial building in the United States is 53.7 years old. That's old. The 80% of the existing commercial buildings in Europe were built before 1990. Some of them a long time before. And then in China's period of reform and reopening began in 1978. But many buildings were completed during the first 20 years of this epoch, and they're going to need to be modernized. So all of a sudden, the biggest market for new lifts in the world is becoming a big market for modernization, and that'll only grow with time. So the number of buildings needing lift modernizations is huge. It's just absolutely huge. But how will the post-pandemic workplace be different? It will be different. And what we see as the differences are we're working remotely, and we've all learned that we can work remotely. A lot of people didn't think it was possible, but we found out of necessity, I guess, that we could work remotely. And there's advantages and disadvantages to working remotely. The advantages are higher productivity. People have found, there's been studies made that people are more productive working remotely than working in the office. There's no commuting. So no commuting means you have more time to work, or maybe more time for yourself and for your family. And it's also a green thing. Not commuting saves a lot of, reduces the carbon output because you're not taking your car or a train or anything to work. So there's some environmental advantages by just not commuting. Also, if you've ever commuted into, like I have commuted into New York City every day for a year, and it's a very nerve-wracking thing to do in your car. Then more flexible hours. You can adjust your hours that you work to meet your schedule, because you don't have to be there at a certain hour, except you may have to be on a Zoom meeting at a certain hour, but it's a little bit different than having to be at work at a certain hour. And so these are some of the things that are very attractive to people. And a lot of these advantages, the workforce doesn't want to give up. They don't want to completely return to that. Disadvantages, and there are very serious disadvantages. One of them is teamwork is difficult. We have teams, we have meetings, but it's not the same as working in the same room with people. Limited mentoring and guidance. It's when you're working with people together, there are mentors that can help you, that can answer your questions. It's a lot easier to do that one-on-one in the same office than it is remotely. It can be done remotely, but it's not so good. And then corporate culture is difficult to maintain. And corporate cultures are very important. Companies are successful because they have a successful culture. And when you can't really build that culture when you're all working separately. So working remotely, there's a lot of surveys have been done of real estate people, and they think that only 60 to 80% of the workforce is expected to return when everything is clear. That's a big, big number, because that means 20 to 40% of the people aren't coming back. So there's going to be some very serious consequences of this. And most people are going to work hybrid, which means that they won't either work remotely or work in the office. They're going to spend so many days a week in the office and so many days a week remotely. But the net result is that there'll be, it's only between 60 and 80% of the former workforce will be truly working full time. Big, big, big numbers that's globally. No, that's in offices. That obviously people working in factories have to go back and work in factories. And there's certain functions that you can't do remotely, but a lot of what goes on in office buildings, almost all of what goes on in office buildings can be done remotely. So working remotely will cause an increase in office building vacancy. Look, if 20 to 40% of the people don't come back, you need only 20, you need 60 to 80% of the office space. So you're going to see vacancy rates increasing. They've already started to increase, but there's a delay in this because people have existing leases that they have to fulfill. But when that lease expires, they'll be looking for potentially very much less space. So that has some impact on competition. Create a more competitive marketplace. It's just going to be more competitive. The supply is larger than the demand. And so when that happens, we tend to get some equilibrium, which means the prices have to come down and things are going to change. So this is going to affect the modernization, because are you going to, if you have a choice between two buildings and one has modernized new elevators and the other one has older doggy looking lifts, well, if everything else is equal, you're going to pick the one with the good lifts. And so it's people compete on modernizations. And what you generally find is the modernization business is counter cyclical, in that when you have new construction booms, you don't have a lot of modernization. When you have a surplus of offices available, you have a bigger, stronger modernization market to help the older buildings to compete. They have to modernize to compete. So it's actually one of the benefits of the lift industry is that we although we have building cycles, we have the counter cyclical side of modernizations. So in the post-pandemic workplace, there's going to be some differences in how we work. So more space is going to be required. More space for social distancing, but also space with less distractions. The concept of boiler room offices where everyone's next to each other, and that it turned out not to be so productive, because people want space for better concentration. And so you can't get as much done when you're working under those conditions. So a situation like this, where you have what desk after, not even desk, like giant tables and people working next to each other, it's not going to happen. That's going to go away. And an office like what's shown in this picture here, where it's desk after desk after desk, and there's not even any separation between it other than this glass divider here in the middle, that is going to go away too. And so you have some alternative things that were proposed during the pandemic, such as this, where you have every other one of these little desks is unoccupied, but that isn't going to work either. So that's not going to happen. So what will happen? Well, the cubicle is back. People are going to want to have cubicles once again, where they can have privacy, where they can have peace and quiet, and more separation. So social distancing, it's here to stay. And other aspects of this are people in the post-pandemic workplace want a touchless experience. They don't want to touch things, and so they don't want to have buttons to have to touch, and they don't want to have handrails to hold, because we all know those are potential vectors to spread disease, but particularly so we found that out with COVID. And people aren't going to forget COVID. And the longer it goes on, the more we're going to remember it, and the more we're going to demand changes. So one of the ways to do this is destination dispatch systems can be touchless. And here's an example where you have kiosks which require people to touch, but there's no buttons in the car. So you have one less set of touch points. You can also have where you have integrated turnstiles. This happens to be the One World Trade Center. So you have your security badge that lets you into the turnstile, registers your destination, and you actually see at the turnstile, it tells you, please use lift number A, for instance. So now we're only down in this scheme to things to touch on the upper floors in the hall. There's nothing to touch in the car. There's nothing to touch at the ground floor lobby, but to get back to move from between floors or back to the lobby, you have buttons to push or a kiosk to touch, a touch point in the lobbies. But if you use apps, smart devices can be used, and so all of your requests for which lift you want to, or which floor you want to go to, can all be done from your phone or your other device. So then you have, with destination dispatching, a totally touchless system. And that's what people want. And I think that's what we're going to see. People are going to be modernizing or upgrading their lift system so that it can be touchless. Now, escalators are another problem, a little bit different problem, because for years we've been telling everybody to hold the handrail. And you know, there's signage at the ends of escalators all over the world that say, hold the handrail, hold your kids. So how can we make a touchless handrail? Well, we can't. We cannot make touchless handrails. So we have to address that in a different way. So what we can do is we can make them sanitary. And so there are methods today to make them sanitary. The one that works the best is to use UVC light. That's ultraviolet. The C refers to the frequency band of the light. There are systems that just basically sanitize the handrail. The UV light is shine onto the handrail in places where people don't see it. UVC is not something you want to have on your skin or anything. It's because fortunately it doesn't exist on here, because all of the UVC from the sun is filtered by the atmosphere. But it also is a frequency of light that doesn't do a lot of damage to things like handrails. So you can see here in this spectrum that you have the visible light section here, and you have UVA, UVB, and UVC, and this happens to be how fatal it is to bacteria and to viruses. So you're probably going to see these added to escalators everywhere. And so they're just actually a type of a light source that irradiates the handrail as it goes by with ultraviolet light. So we're going to see this. Now this is not necessarily modernizing, but it's a part of a modernization or part of an upgrade program to make these much more sanitary. Now we also have forced social distancing, and this is an interesting picture because we see here there's a guard here, and he's wearing a mask, and you have 5 people, only one is wearing a mask, and they're separated a little bit. And the thing is, this doesn't, probably without a guard, there wouldn't be any social distancing going on at all. And that's human nature. But this type of social distancing in lifts, I don't think will really work with real people. So social distancing as a result of remote working. Let's take a look at an example of how does this affect the traffic in an office building. So if we're going to have social distancing, is it going to have an impact on the traffic? Yes, definitely. So let's take a look at a sample building here that is what the specifications are. It has 6 lifts. It has 1,350 kilo capacity, 3 meters per second, 18 stops. And pre-COVID, there were 54 people per floor. Now, if we take the 54 people and we say, well, what's 80% of that? It's 43. So now instead of having to transport 54 people to each floor, now we're only going to transport 43. That's good for traffic handling. So so that's 43 people, and so if we're going to use simulation here, elevate simulation in an office building template. And here we have, with 100% occupancy, like everybody's working there, we have 21.21 square meters per person as a limit. And here's what the results we get with a group control, a standard group control system. Waiting time of 9.3 seconds, transit time of 70 seconds, and time to destination of 79.3 seconds. Not bad. But take a look at the car loading. This is on departure from the lobby. And you can see here that the average load at some point during this period is like 9 people in the cabin. And the peak is like 14 people. So there's no social distancing there. But if only 80% of the people come back, and we allow them a half a meter, square meter, 0.5 square meters per person, and using touchless control, which implies destination dispatch or ACA, the waiting time is 19 seconds. Well, that's not bad. It's not as good as 9. But look at the transit time, 36 seconds, half the time. Now you're only going to be exposed to the other people half as long. That's a good thing, very good thing. And then your time to destination overall is considerably less. But look at the car loading numbers here. The average is about 4 people and the peak is about 6. So you're going to spend less time with less people, and you're going to be able to handle the traffic in the building, even though you've got to have more social distancing. So in this case, social distancing doesn't hurt the system because you're going to have less people, and inherently you have fewer people in a car with the destination systems than you would have with traditional. I think, to me, the most important thing is to look at the number of people and how long you spend with them. Now, this is long. This is during the morning upbeat, but lunch is some of the most difficult traffic that you have in modern buildings. So let's see what the impact is there. So here we have lunch. Again, you look at the car loading here. It can be on average like 7 people and 13 people during a peak period. So we get with group control, and we have waiting time of 24 seconds, transit time 64. That's the time. This is the exposure time to the other people, and time to destination 89. But if we go to 80% occupancy, half a meter per square meter per person, and with touchless control, the waiting time is about the same. But look, transit time much lower. Again, almost half. And time to destination is better. But look at the number of people you're going to be riding in the same car with. It's a peak of 5 and on an average of 3. So good separation. So destination dispatch is going to be a solution that people are going to want to deploy, because it reduces your exposure time and the number of people to whom you're exposed. You win on both counts. So another thing that people are very concerned about is ventilation. What is the quality of the air? We know that if you're in places with good ventilation, open air, there's less transmission. So what are the solutions for that? Well, here's a sample of a system where you have a blower, and notice that this blower is blowing air into the cabin. Most of the lifts in North America have exhaust fans, and they just draw the air in from the hoistway or the lobby into the car. In Asia, most of the lifts have inlet fans where it blows air into the car. In these newer systems, you're going to need to have a blower that blows the air into the car. And then it goes through an ionization chamber. And an ionization chamber ionizes the oxygen into ions, negatively and positively charged. Some systems and they blow this air into the cabin. Some systems put a filter in, and there's a discussion about, is it better to have a filter or not have a filter? I think not have a filter, because the filter probably won't get clean. And then it works fine for a while. But one of the things that is actually happening is that these ions are being blown into the car, and they go in there. And so they don't just clean the air before, purify the air, kill the virus in the chamber. They're now floating around in the cabin. And what they'll do in there is because they are charged particles, if you will, they will attach themselves to the virus, and they end up killing the virus. So you have the fact that this air that's blowing in is keeping it away from you, but when these ions find a bacteria or a virus, they work equally well. They will actually go and kill it. So, and these things can be easily retrofitted to existing ventilation systems. Even if you have like a North American type exhaust fan, you just turn the fan around, have it blow the air in and put the chamber on the other end. These are available, they're being installed, but I think you'll see them on just about everything going forward. No reason not to. So other new technologies, and this is a big one, connectivity. Everybody wants connectivity. Everyone's connected with your mobile phone, with your laptop, with your tablet, and that's a big thing. And also machine learning that comes along with connectivity. So connectivity, well, we have a lift controller. All we need to do is add a modem, send the data of what's happening with the lift to the modem. From the modem, it sends it to the cloud where there's an API, which is an application programming interface. We'll go into that, what that means. It's in the cloud. And from there, it goes down to your phone and you have apps. What kinds of apps would you have? What kind of apps do people want? Well, there's apps for building managers that let them know the condition of the lifts. Are they all running? You know, when are they being maintained? There's apps for building engineers that give them more technical information about their lifts, and there's apps for passengers. So and some of those apps might be apps for touchless operations. So you'll be able to call the lift from that app. A user interface is how humans communicate with computers. And an API, application programming interface, is how computers talk to each other. And so these the APIs will be created that can communicate with all these other applications. Let's look at what some of those applications might be. Well, for one thing, the security system can communicate with the API, and that's why you can, when you swipe your card, your ID card, that it lets you know which lift you can take, and because you're permitted to go into the building. Additionally, you have them tied into the building management system. So the lifts are now communicating through the API to the building management system. You also have robots. So the robot can now call the cars to it. Say, I'm on 3 and I want to go to 7. And so the robot is basically going to be addressing an API. The facilities management system can do that. It's a little bit different from building management systems. A lot of facilities management companies are keeping very good track of lift maintenance, air conditioning maintenance, this type of thing. And so their systems are going to want to access the API and get information. And well, yes, big brother, there are government agencies now that want to keep track of what's happening, and they are requiring APIs for their use. So connectivity creates large amounts of data. Just that we're now connecting to the cloud, we're gathering lots of information, and that's known as big data. And big data means just a whole lot of data, that's what the name implies. And that's data that can be analyzed. So that's very important. So how do we analyze this data? Well, that's we have the lift controller, we're communicating to a modem, we send it to the cloud, but then we have programs that are machine learning programs, and they process all of this data and make predictions and send it down to our phones. And we have apps on there that allow us to know, like to the technician, oh, you're going to need to change this bearing within the next 2 weeks to avoid a shutdown. So machine learning makes predictions based on known properties learned from training data. And so there's several types of many forms of machine learning. A couple of the more common ones are expert systems, fuzzy logic, and the two that are used primarily now for lift applications are CART and artificial neural networks. Now CART, it stands for classification and regression trees. And this has been used for the last 40 years, I think now, in aviation. And that's one of the reasons we have so few aviation accidents, other than pilot error, which CART doesn't help with. Although you can use machine learning to evaluate personnel. And so what does a regression tree look, or a classification tree look like? This is a classification tree for determining what kind of fruit something is. Now, that doesn't look like a tree. If you turn it upside down, then it looks like a tree, and that's where the term comes from. But here you say, well, okay, I'm trying to figure out what fruit I have here. So, well, it's red. So, okay, I go down here. Is it small or is it medium? Well, it's small. Well, then I'm going to taste it. And if you taste it and it's sweet, well, that means it's a cherry. If it's sour, it's a grape. So this type of logic is what's used to take data and predict, to tell you what you have in the way of a fruit, or when this bearing is going to fail on the machine in your lift. The other type of learning that's being used a lot now is artificial neural networks, ANN. So this is a network with a neuron, which is a nerve cell, and the nerve cell has inputs, and then it's connected to outputs, and that's how a true human nerve cell looks like. Here's what an artificial neural network looks like. It has a layer of inputs, like here. It has a hidden, one or more, and sometimes a whole lot more hidden layers, and then it has an output layer that processes things. And that's similar to how cells are arranged in like your brain. But these simple artificial neural networks need to be trained. And a simple network might have 6,000 neurons, so it's not a small thing. There's also something called deep learning, which is just a whole lot of layers, but it's essentially an artificial neural network, and it needs no training. So it just sits there and it will learn on its own what part's going to fail and when it's going to fail, and you don't have to train it. So that's just takes a lot more processing, but it's still there. And so they're very good for pattern recognition. And so this is a door operator motor, and one of them is, it's the same motor. This is its pattern of how the vibration that it has on a motor that's in perfect condition and one that's damaged. And they're so different that you can determine which one, whether it's good or bad, like with accuracies in the over 90% range. So vibration and sound patterns can be used to predict the remaining life of components. So it would be nice to know that this door motor is going to fail in 3 weeks, so you can get there in the next 2 weeks, change it, and avoid a trouble call. So with data, we can also, all this big data that we're collecting, we can work with the customer to establish what's the right amount of service. Too much service raises costs and has no benefit. Too little service causes complaints. And we can, when to perform service? Well, from traffic data, we can reduce disruptions. We certainly will know when there are peaks in traffic and when there are lulls. We can schedule our maintenance so we disrupt the building a minimum amount. And when to modernize. So we know we modernize every 15 to 30 years, but by gathering all this data, we can recommend to the customer, no, it's getting time to modernize. You should start budgeting because you're going to be ready in 2 years. So all this big data is a tool for modernizations. Artificial intelligence. It's not just for the executives of lift companies. It's a great thing to increase operational efficiency, and that's what benefits the lift company, operational efficiency. So we'll only perform the maintenance that's required. We'll eliminate unscheduled callouts. An unscheduled callout is a very expensive thing. Answering a trouble call at 2 in the morning is very expensive. And it increases customer satisfaction. Why? Because customer has fewer breakdowns. That makes more uptime. That makes them happy. And and a faster return to service, because even when you do have a breakdown, you'll know about it. You'll get it back running again. It's much better. So conclusions from all of this are modernizations will be driven by societal change as a result of COVID-19. The things are going to be different, and we're going to modernize differently. And innovation such as connectivity will also drive modernizations. And I think there's going to be a lot of modernizations now because of the need to be more competitive and the need to change the workplace to be a safe place to work. So thank you, and I think we're ready for questions.